Well, most of the times, jobs started off, we put up conduit. So, we got all sizes of conduit. Not everything's going to look just like this. This is EMT conduit. Most times you see this inside buildings or housing. And this is a 90-degree piece of conduit. When you run a conduit, you need to get somewhere. As I will say, this box. You get a solid piece of conduit. There's 90 degree. Making nipple, you make the boxes together so you can pull your wire in there and wire up whatever it is that you need. And then once you pull your wiring, whatever you're going to, either a transformer, a disconnect. We also got a start-stop button over here. Most time you see the start-stop buttons a lot in the industrial field for motors. These are control wiring. Let's take the front off if you look at it. This is for the operators in the field. You got a motor. They're out there, they need to start it, start, stop. That's where we come in, we wire it up, so make these for the operators. We all have these wiring diagrams. You go by the diagram, hook it up. So you trace the diagram out. Your black wire will be in one. Most of the electrical, you got black, red, and blue, 1, 2, and 3. It's pretty simple once you get the hang of it. Follow it out, your one goes onto the stop on the normally closed. On all these switches, they got a little number right there that says normally closed, normally open. They're labeled, easy to identify. Then you go through, you find number 2. Goes on your black wire. And your red wire, I'm sorry. On your start. You're going to find your 3 on your wiring diagram. It's going to be on the normally open on the start. And what normally open, normally closed means is normally open, your contacts are always open. And normally closed, it's simple, your contacts are always closed. So for example, on the stop button, it's always closed, so you're always going to be sending power to your start, because these are normally open. So when you push that down, it'll close the contacts, and that's what will get your motor to start. And then you guys follow a jumper. What you have is you have your black wire coming out on your normally closed on the stop. It jumps over, because these normally closed contacts, it jumps to your normally open on your start. So when they stop that motor, you push that stop button, it opens up those contacts, and that kills the power to the motor. So they can stop and start whatever they need to get the process going through the pipes or whatever they're doing. This will be a starter. You'll find this inside the MCCs. This is the bucket. If we're in a refinery, in this hole right here, you would have your leads going to your motor outside. They come to the bottom of your breaker. These are our wires going for our start-stop. These are control wiring on the side of the box. Right here we have a transformer, flathead. We need to step up the voltage or step down the voltage. What we use the transformer for. You'll see there's a lot on the lighting panels. You need to come with the higher voltage. You need to drop it down to power up the panel. On the transformers, it shows your wiring diagram right here on top. Your H's are your primary. Your X's are your secondary. And then you also gotta install your ground wire. Everything needs to be grounded because it's electrical, so if something was to fail, it will go to ground. It prevents you from getting hurt. And all your wirings will have a tag on it or a number, so you can identify yourself. You're not just gonna walk in and see nothing but colored wires and not be able to identify it. So if I can explain it to you better, once you get in the field, you'll learn more. But there's all different kind of transformers. If you go inside your house, look on the light pole, you'll see it. It's a big cylinder. That's a transformer. They all look different, but they're pretty easy to wire up. Got an easy diagram. Over here on this piece of plywood over here, there's some things that you would see every day being in the electrical field. These are your fittings for your conduit. You put these there so far so you can pull the wire in, or if you have to stop to hit an instrument or whatever you need to, makes it easy. These are all different kind of hardware that we use every day doing this. You got REs to little nipples to put your fittings together. These are seals in the explosion-proof areas. You need to put these, prevent a spark from the instruments inside. Here's more material, more fittings, more hardware that we use all day. I think they did pretty good. One of the main things about working in the industrial field is safety. When you come into the job site, you always have your hard hat. You would have your gloves and your safety glasses. Depending on the refinery, you have to wear monitors if they have gases there to protect yourself. Not all places are the same. Some places are different. But one thing about electrical is anywhere you go, electrical is dangerous, and you got to protect yourself. We got these high voltage gloves. Checking voltages and panels to verify that they're dead. They're rubber. That's how it's leather gloves. It's insulated. It prevents you from getting shocked if something was to be live in there. Sometimes that's with high voltage. Get this jacket. It'll help. There's arc blast. It'll help from you getting burned. It protects yourself. You put the jacket on. They got leggings for it as well. Don't see that. You also got this hood that you need to wear. It protects, of course, your face, your neck area. It is tinted, so there was a flash. It wouldn't hurt. It'll prevent your eyes from getting, blinded by the light. But you have to know what you're messing with. Know the densities. Every voltage has a different boundary. The higher the voltage, the more protective equipment you need. The further distance you need to stay away from it. It all depends on the voltage, but everything's the same. You never touch a wire without verifying that it's dead. Protect yourself. You don't want to get hurt.